All right, so there's two parts to this practice quiz 6.3, 6.4. We're going to focus in on this first part on writing radical functions and inequalities given the graph. We're going to be looking at graphs, analyzing graphs, and pulling all the information that we need to write the actual function or the inequality of the graph represented. Let's move on to the first question here. So it's saying, which of these could this graph be? Of course, you could graph each one of these on Desmos, but that would take a really long time. Let's zoom into that graph and let's understand something. This graph, this square root function came from a parent graph. And the parent graph of any square root function is y equals the square root of x. That's the easiest parent graph, the easiest square root function that you could actually graph. Ultimately, this is what we want. We want y equals a. That'll tell you if it reflects over the x-axis, if it gets vertically stretched or compressed, times x minus h, and then the outside value is a plus k. Actually, I should have done that in red, plus k in red. Okay, so this is the form that we want. Again, the a value tells you if it opens up or if it opens down, if it gets vertically stretched or compressed. And the h and k normally tells you, it does tell you the most important point. On a parabola, it tells you the vertex. Right here on a square root function, it tells you the beginning point, right? Or the end point, if you want to call it. But anyways, the parent graph y equals the square root of x. That is, it looks like this. Shoots off in that direction. And the parent graph goes forever up and forever to the right. So it'll keep going forever up, forever to the right, the parent graph. So obviously, oh yeah, you know what? Just to remind you, if you're thinking, where the heck did he get this? How does he know that the parent graph looks like that? If you go to an input-output table on the parent graph and you plug in the number 0, the square root of 0 is 0. So the input 0 gives you the output 0. And that's why we have a coordinate at the origin. The input 1, you could actually do the square root of 1, and the square root of 1 is 1. So the output is 1, okay? So that's how you get 1, 1. You don't want to plug in 2 because the square root of 2 is an ugly decimal. The square root of 3 is an ugly decimal. The square root of 4 is a nice answer, 2. So if I kept going with this 1, 2, 3, 4, 1, 2, it should be up here. So it should continue going that way. So anyways, you should get the idea of the parent graph. And this parent graph goes through transformations to get to this one over here. So first things first, it will reflect over the x-axis because obviously it's opening down, not up. So the a value must be negative. And not only is it negative, like let me actually show a reflection of that parent graph. It would be like so, because that one gets reflected over the x-axis 2 units down, which would be right here. So this green one would be the reflection of the parent graph. Now, compare this green one with this blue one. From here to here, it's down 1 over 1, right? From here, it's not down 1 over 1, it's actually down 2 over 1, which means that it got vertically stretched, okay? So first thing is that it reflects because it's negative, and then it gets vertically stretched because instead of it going 1 down, 1 over, 1 down, 1 over, it looks like it's going 2 down, 1 over, which means that the a value of this blue function is actually a equals negative 2. Okay, so that's the a value of that function. Now, what's the most important point of this blue function? That's the coordinate negative 3, comma negative 1. Okay, so the h value is negative 3, and the k value is negative 1. So what we want to do here is write the actual equation. Y equals a square root x minus h plus k. So let's do that. That will be y equals a, we said a is negative 2, square root of x minus h, x minus, and h is a negative 3, so that's a negative 3. So we know that that's going to change to a plus 3. And then we also have the k value being negative 1, so plus the k value of -1. And of course, we don't need a plus negative. We could just write a minus right here. But anyways, this is our answer. So let's go back to the question. Which of the following multiple choice options is this one? Y equals -2 square root of x plus 3 minus 1. Y equals -2 square root of x plus 3 equals -1. And as you could see, it's nowhere to be found. So the correct answer must be none of these are correct. Another similar question, it says, which one could the graph be? So again, let's zoom into the graph and let's think of the parent graph and the transformations that it actually goes through to get to this new graph, all right? And we'll be able to identify the A, the H, and the K, and we'll know which one it is. I know it's kind of blurry, I apologize, but once again, the parent graph, y equals the square root of x, that starts right here at the origin. And if we did make a table for the parent graph, the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. Now, why didn't I plug in 2 or 3? Because square root of 2 is ugly. It's a crazy decimal. Square root of 3 is a crazy decimal. Square root of 4 is nice and neat. And remember, I could plug in any numbers I want. So I plugged in 0 because the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. So these are actual coordinates. 0, 0. We need 1, 1. 1, 1 is right here. And 4, 2. 1, 2, 3, 4, 1, 2, right there. So this is the parent graph. Now, of course, I could have kept going and plugged in the next perfect square number, 9. The square root of 9 is 3, so that'd be 9, 3, right? So it would keep going. But anyway, this graph, as you could see, it looks almost identical to this one because this one does go, let's say, 1 up, 1 over. Same thing, 1 up, 1 over. So this is the same exact A value. Okay, so once again, the form that we want to write it in is y equals the A value square root of x minus h plus k. Plus k is on the outside. And we need to remember that the A value tells us if it gets reflected over the x-axis. If it's negative, it opens down because it got reflected over the x-axis. If it's positive, it's opening up. This one's obviously positive, just like the parent graph. And it also tells us if it gets vertically compressed or stretched. So it's definitely not negative because it opens up just like the parent graph does, right? And it doesn't get vertically stretched or compressed because if I compare the first two dots on my parent graph, up 1 over 1, okay? This one's up 1 over 1 as well. Now, what if it would have been up 2 over 1? Then the A value would be 2, positive 2. If it were up 1, 2, 3 over 1, if it shot up through there, then that would be the A value of 3, right? So it is up 1 over 1. So the A value is 1 on this guy. So A value is 1. The H and K value, it's just that beginning point, that most important point. And that is the coordinate 2, 1, 2, 3, 4, 5, I believe. Let me see, 2, 1, 2, 3, 4, 5. Yep, 2, 5 is that important beginning point or end point, and that is the H value of 2 and the K value of 5. H is 2, K is 5. So once we know the A, the H, and the K, we will be able to write our equation. And our equation is y equals A, which is 1, but you don't even need to actually write the 1 right there, right? You could just erase it. X minus h, I'm going to erase the 1 just so it'll look cleaner. X minus h, the h value is 2, and then plus k plus 5 on the outside. This is my answer. Let's look for it. Y equals the square root of x minus 2 plus 5, and there it is. Y equals the square root of x minus 2 plus 5. Let's move on. Select all the true statements of this graph. Well, it'd be better to actually see the graph. Let's zoom in to this guy so we could clearly see what's going on. So I'm just going to cover this up down here so we don't look at anything else. Okay, so anyways, we have the beginning point right here. And that's the most important coordinate, the end point or the beginning point, which is -2 on the x, 0 on the y. So your h value is -2. Your k value is 0. Okay, and it does go down and to the right forever. It always goes down and to the right forever. Probably should have drawn an arrow right there. But anyway, let's start reading through this. The domain is x is greater than or equal to -2. Well, remember, the domain are your x values, which is to the left and to the right. And it does have an x value of -2. So is the graph on the left side of -2 or on the right side of -2? It's on the right side of -2. So that's saying that your x's are -2 and greater, okay? So the domain is x is greater than or equal to -2. That is absolutely correct. So check that one. That's one correct one. What about the range? The range is y is less than 0. Well, the range are your y values. So they got the y correct, but less than 0 means that it cannot actually be 0. Now, what it should be, the range should be y is less than or equal to 0. So because there is no or equal to, that would make this a false statement. Okay, so the range is less than or equal to 0, not just less than 0. So that would be incorrect because that is wrong. It should be y is less than or equal to 0, not this guy, right? So don't pick that one. Moving on. The input 2 gives you the output 2. Remember, inputs are your x values, outputs are your y values. So does this graph exist at the input 2, output 2, at the x value 2, y value 2? So the coordinate they want you to check is 2, 2. So 2 on the x, 2 on the y. The graph is definitely not up there. It's not 2 on the x, -2 on the y. So this is incorrect as well. What's wrong about it is that it says output 2. If that would have said that the output is -2, then it would have worked, but it says +2, so it doesn't work, so don't pick that. Again, input 2 should give you the output -2, because the coordinate is 2, -2. And right here it says 2, +2. 2, +2, the graph's not up here, it's down here, okay? So the next one, the graph is the function y equals -square root of x. There is no h plus k, plus 2. So it does open down, but the parent graph, again, the parent graph, y equals the square root of x, that starts off at 0, 0 because the square root of 0 is 0, and then it goes up to 1, 1 because the square root of 1 is 1, and then it shoots off in this direction to the coordinate 4, 2, and then 9, 3, and then 16, 4, etc., etc. As you can see, it does reflect over the x-axis, so the a value should be negative, which it is, that's great, but this is a k value of 2, so does it reflect this way and then shift 2 up? No, it's incorrect. It shifts 2 to the left. So what that should have said is y equals -square root of x plus 2 on the inside of the root, as the h value being -2. So x plus 2 on the inside of the root, not plus 2 on the outside, because that's a k value, which causes it to shift up, not to the left, okay? So that's also incorrect, okay? So don't pick that one. So the only one that's true here is the domain. Let's move on. So on this one, we're selecting the true statements. It says there was no reflection over the x-axis. And we know that there definitely was a reflection over the x-axis on the transformation from the parent graph to this graph, because the parent graph starts at 0, 0 and it goes up in this direction. And we know that that's not going up in that direction, up to the right. It doesn't happen that way. It's going down to the right. So instead of up to the right, it has to get reflected to go down to the right, even before getting shifted 2 over and 3 up. So right here it says there was no reflection over the x-axis. That's wrong. For sure there was. There's definitely a reflection over the x-axis from the parent graph to this graph. Okay. The next one, the input 2 gives you the output 1. That's telling me that if I go to the 2 on the x and the 1 on the y, the graph will be right there, and it definitely is. This graph that we're looking at does have the coordinate 2, 1. So input 2, output 1, absolutely, that is correct. That's one of the true statements. Maybe there's more. Let's keep going. The input 14 gives you the output -1. Dang. Well, we obviously can't see the x value of 14 and see if it goes down to -1. We don't see that part of the graph. So what we need to do is actually write down the actual radical equation that produces this graph. Now, in order to do this, I want to zoom in on the graph, make it more clear. So here's the graph, and of course we want it to look like this. So let's think about the original parent graph, the y equals the square root of x, and of course the square root of 0 is 0, the square root of 1 is 1, and it is going to go up and curve in that direction, and it does continue to go in that direction because we know that the next input would be 4. Square root of 4 is positive 2, so it'd be up here, right? But anyway, that's the parent graph, so we know it has to get reflected over the x-axis. So the a value, it has to be negative. It might be -1, it might be -2. Let's find out. Now, the reason why I say it might be, well, if it gets reflected, then it should have, let's actually reflect it. It'd be down here, okay? So as you can see, the pattern on the reflection is down 1 over 1. So does this one actually have the pattern down 1 over 1? Well, it's not really a pattern, but from the first point to the second point, is it down 1 over 1? The answer is yes. So it did not get stretched, right? So that must mean that the a value is -1, okay? Now, if I were looking at this graph and it actually went down 2 over 1, like if the red line went like this, through this point right here, then that would be a vertical stretch of 2. Of course, the a value would become -2 because it went down 2 over 1. But that's not what's happening here. So let me erase it. What's happening here is that it goes down 1 over 1. So it did not get vertically stretched. It did not get vertically compressed. It's exactly the same as the parent graph. When I do the square root of 1, I get 1. So that's why it's a coordinate 1 up, 1 over. So right here, down 1 over 1. It didn't get vertically stretched or compressed, but we know it's negative because it got reflected over the x-axis. Now let's talk about the HK, the most important coordinate, which in this case is -2, +3. So the H value is -2 and the K value is +3. So our equation will be y equals -1 square root x minus -2 plus 3. So let me rewrite that. Y minus square root x plus 2 plus 3 on the outside. So this is the function that produces this red graph, okay? So let's go back to what they were asking. Is this a true statement? The input 14 gives you the output -1. What you need to do is actually input 14 into the x, okay? And you know what? I forgot to put y equals. That should be y equals negative square root of that stuff. So let me rewrite it. Y equals negative square root. Okay, so if I plug in 14 right here, 14 plus 2 is 16. The square root of 16 is 4, but with the negative sign in the front, it's going to be a -4, and -4 plus 3 is -1. So the input 14 really does give you the output -1. So that is another true statement. And then it says the graph is y equals square root of x plus 2 plus 3. We know that that's incorrect. It should be a negative in front. The a value is negative. So don't pick that one. So these are the only true statements, the only 2 true statements on this question. Let's move on to the next one. So we are finally to some inequalities. We're going to look at the graph and we're going to identify which one it is. Let's zoom in and look at it. So once again, let's think of the parent graph, the y equals the square root of x. The square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2. So 0, 0, 1, 1, and 4, 2. So that's what the parent graph looks like. Yeah, it's kind of ugly, sorry. But anyway, as you can see, it's the same curve. So it didn't reflect over the x-axis. It didn't get vertically stretched or compressed, right? From here to here, it's 1 up, 1 over. From here to here, it's 1 up, 1 over. So the a value must be 1. Once again, the form that we want is y equals a square root of x minus h on the outside plus k. All right, so we have confirmed that the a value, it didn't get vertically stretched or compressed, it didn't reflect. It's the same exact pattern from here to there, right? So the a value must be 1. The a value is 1. What about the h and k? Let's go to the h and k right there. That is the coordinate 1, comma, negative 2. So the h is 1, the k is negative 2. H is 1, k is negative 2. So our equation, our radical equation is y equals 1, which you don't even need, square root x minus h, plug in that h value of 1, and then on the outside plus negative 2. Sorry about the change in audio here. We still need to represent this shaded area, which is below. So technically it's not an equal sign. If it were an equal sign, it would just be from here shooting off in this direction forever. But because we have an area that's shaded, then we need to represent that area with the inequality. So this is obviously a dotted graph. So it's either going to be less than or greater than, and obviously it's shaded below. So shading below would be a less than symbol. So all we would need is a less than symbol right here instead of the equal sign. So y is less than, you don't even need the 1, the square root of x minus 1, and then minus 2 on the outside. This guy right here is the correct inequality. Again, if this graph would have had a solid line up here and shaded below, then that would have been a less than or equal to with a solid line underneath the inequality. Let's select the correct answer here, and we will see that it is that first option right here. Here's another one where they give you a graph and you need to analyze it, come up with the a, the h, and the k, and see if it's shading above or below, and select the correct one from there. So let's take a look at the graph. And once again, we see that it is dotted, so immediately you could eliminate the ones that have the or equal to. This guy and that guy, you could eliminate those because this is definitely not a solid line. Not only that, you are shading below, so you already know it's going to be a y is less than, not a greater than, so it can't be this one either. Okay, so you're down to one option or none of these. But let's actually walk you through on how to actually write the entire inequality. So once again, we want this, and we do know that the a value must be negative 1 because it's not, the parent graph would start here and go up to 1, 1. Obviously, it gets reflected to open down instead of opening up. So instead of opening up from 0, 0 to 1, 1, it's going to go from 0, 0 to negative 1, or positive 1, negative 1 right here. That's the case. It's going down 1 over 1 to get to there. So it didn't get vertically stretched. It didn't get vertically compressed. It just reflected over the x-axis. So we know that our a value is a negative 1. Okay, I'm just going to put a negative 1 right there where the a is at. Now let's identify the h and the k, and we will have our inequality. Of course, that's shaded below, which means that that must be a less than symbol. A less than symbol. Okay, so what is our h and our k? Here's the point, the most important point, that endpoint, which is the coordinate negative 2, comma, positive 1. So we're going to plug in an h value of negative 2, that's our h, and our k value of 1. So negative 2 right there, k value of 1 right there. The only other thing you could do is change the minus minus to a plus plus. And there's our inequality. Y is less than negative. You don't need a 1. You could just write the square root of x plus 2 and then a plus 1 out here. Let's verify if that's the inequality that's provided to us. And yes, it is. So this is the correct answer. Let's move on to that next question. Select all true statements of this graph up here. Well, the a value must be negative. Absolutely, because it's not opening up, it's opening down, right? So the a value must be negative, absolutely. Let's look at the next one. It looks like it got vertically compressed. Compressed means that it got smashed. Now we know that the parent graph, if you remember the parent graph, y equals the square root of x, it has the square root of 0 is 0, but the square root of 1 is 1. So from 0, 0 to 1, 1, there's a pattern of, and you can't really see it here, but the pattern is it goes up 1 over 1. So if it just reflected over the x-axis, then it must be going down 1 over 1. But as you can see right here, it doesn't go down 1 over 1. There's no part of the graph right here. It's actually going down 2 over 1. So that must mean that the a value is -2, okay? So our a value is -2. So we have y equals -2, and then you have the square root of x minus h, and then plus k on the outside. And the h value and the k value are -3, -1. -3, -1. Okay, anyway, -3, -1. So it looks like it got vertically compressed. Absolutely not. It got vertically stretched by 2. So it does get reflected over the x-axis, then vertically stretched by 2, not compressed. Okay. What else? The h value must be 3. That's definitely wrong, because the h value is -3. Remember, the beginning point is the most important point, kind of like a parabola. The vertex is the h and k. Right here, this end point right here, this beginning point, -3, -1, that's the beginning point. That's the most important point. So your h value is -3. So when I plug it in as a -3, but that minus in front of it, yeah, when you look at the equation, it looks opposite, and you're going to think it looks like a 3, but that's not the case. The actual h value is the x value of that beginning point, of that end point. So the h value must be -3, not +3, so don't pick that one. The k value must be 1. No, we know that the k value is -1. The k value is -1, so that's incorrect also. The domain must be y is less than or equal to -1. Well, if you're talking about the range, yeah, y would be less than or equal to -1 because the y value is -1 and it's below -1, but that's not the range. I mean, we're talking about domain, not the range, so that messes it up. So if that would have said range, then yes, it would have been true, but it's not. So the only one that's true is that the a value must be negative.